Welcome everyone and welcome to this lecture. What did we do in the last one?
Relations in Einstein equation.
Okay, so we were doing Einstein's equation and I told you Sir Albert Einstein got the Nobel for his work on photoelectric effects, and that is the only Nobel that he ever got.
Yes, sir.
Okay, sir. We have done almost everything that we needed to do, and we have almost covered all the questions that are possible in this particular chapter. Have you got the notes in hard copies?
No, sir.
No, sir. Okay, sir. I mean, this is India, sir. So things takes time, sir. And that is the problem with our country. Anyways, I've already we have already solved everything. And the notes will come. Don't worry. So even if you don't get it, you'll get it today maybe. I've sent one more sheet, two more sheets for matter waves today. So probably you'll also get it. Let us begin this class and let us start with whatever is left, and whatever is left is only the graph. We have already discussed these graphs before, but now we will add one or two more graphs and make the topic well confined and well covered. So let us now, without wasting any more time, move on to doing some graphs, and we'll do 2 or 3 questions that have come previously, and you can see what we are doing as theory, they have come as questions in those examinations. And when I say those examinations, it might be your mains, it might be JEE mains, it might be NEET, it might be CPMT, PMT, doesn't matter. So let me start with this, and I have my dabba here, so I'll just increase this dabba.
Okay, sir.
Make it this. Oops, where this dabba goes. Oops, make it like this and like this. Okay, let me take this entire thing. Okay, so here comes this dabba right in front of your eyes. It's not come. Okay, it has come. Okay, so I think we have already discussed point number 4. Yes or no? If your frequency f is less than your f naught, no emission will take place. Have we discussed this point? Yes or no?
No, sir.
No, sir. Then what will we discuss in the last class? Stars and galaxies. Discuss this. The frequency of the radiation should be greater than your work function. Yes or no? We discussed 3 cases. Energy is greater than work function. Energy is equal to work function. Energy is less than work function. We did not discuss this. Then what did we discuss in Einstein's equation? E is equal to mc square. No, did not discuss E is equal to mc square. If the frequency of radiation is more than f naught, which I say that energy of the radiation is more than work function, or I say lambda is less than lambda naught, I don't think you have gone through the notes. As I told you, whenever you come to first class, you must see what you have done in the last class, else this class gets flushed off. Emission of electrons will only take place if the frequency is more than threshold frequency. Do we recollect it now?
Yes, sir.
Yes, sir. No, sir. Okay, sir. So that's it. That is the last point which was discussed. We had discussed 3 points. This is just a continuation of what we were doing in the last class. After Einstein's equation, and we have seen the relation between kinetic energy, work function, and energy of the photon. What was the relation? Tell me, I have to ask you because now I'm in a doubt whether you remember it or not. Yes. What was the Einstein's equation that we discussed in the last class?
E is equal to W naught plus KE maximum.
Yes, that is correct. So I can write it in this form. 5.1. Do you see this, everyone? Kinetic
Yes,
energy maximum. Kinetic energy maximum is HF minus, they write it as phi naught. I write it as W naught. Yes or no?
Yes, sir.
H stands for the Planck constant, and that nu is basically your F. So basically what I'm writing here is KE max. Let me just Write it and please remember KE max, I'll just write it KEM will be equal to HF minus W naught. Yes or no?
Yes, sir.
Now, if I draw a graph between the maximum kinetic energy, as you can see, maximum kinetic energy is plotted here. Everyone can see this?
Yes, sir. It's visible.
It's visible, but I'll make it more visible so that you can see it. Bigger and bigger and bigger. So let me just squeeze this thing up and bring the new result right. And see, every day you learn something new. So I've learned this thing new, how to make things bigger and put it on your screen. So now do you see it, bacha? Bigger, 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 bigger. You see this?
Yes, sir.
It's very big now. It's on your entire screen probably. So now I have kinetic energy plotted here on the y-axis. We see this, and we have frequency f plotted here. Do we see this?
Yes, sir.
Yes, sir. No, sir. Then, sir, what, sir? We have plotted a graph, and it's the straight line graph. Do we understand this? It's a straight line graph. Y is equal to mx plus c. Do you recollect the graph y is equal to mx plus c?
Yes, sir.
I'm
Straight line.
planning for the slope and this, and that. Yes or no?
Yes, sir.
Yes, sir. No, sir. That is the graph, sir. If I what? If I just write the equation of a straight line and I try to write it very small, y is equal to mx plus c. M stands for the slope of this graph. Yes or no?
Yes, sir.
Y is the kinetic energy. No, y is the y-axis, x is the x-axis. That means the slope c is some intercept. Yes. Now, what I am going to write instead of y, I am going to write kinetic energy ka k because the space is less. So I'll just write k. Do you understand? K stands for kinetic energy.
Yes, sir.
Yes, sir. Is equal to. Now remember the equation for kinetic energy was hf. So I write h f minus w naught. Do we all see this? Yes, sir. No, sir.
Yes, sir.
We see, sir. We understand, sir. Yes, sir.
Yes, sir.
So this m, gentlemen, now becomes your h. Do we understand this?
Yes, sir.
Yes, sir. And sir, what, sir? Next thing, sir, is this thing, sir, that your C. Oops, kahan gaya? Oh, I can't. See. Let me try it again. If I can highlight it. I can't highlight it because by auto it is taking something else. Anyways, doesn't matter. So if I look at this C, and I'll just use a different color pen because I can't highlight it. This C corresponds to your minus W naught. Yes or no?
Yes, sir.
Yes, sir. No, sir. That means when x is 0, y will be negative. Yes or no?
Yes, sir.
And that is the work function that is plotted here. Do you get my point, bacha? So I have drawn the graph for two metals, metal A and metal B. Both these graphs are inclined at the same angle. Do you understand? They are inclined at the same angle because the slope of this graph is constant and the slope of this graph is equal to h. Do we understand this?
Yes, sir.
Yes, sir. So tan of this theta, which is the slope of this graph, which I draw for any metal, the tan of this theta will be equal to h. Do not forget this in your entire life till you give your NEET exam, because this question comes and this will be the thing that they will ask. Tan theta will be equal to h. Yes or no?
Yes, sir.
And then we have the y-intercept. And then you see two y-intercept. One is the y-intercept for B. One is the y-intercept for A. Which one of these is having more work function? You can easily see it from the graph. Which one is having more work function? whether A is having more work function or B is having more work function. You can see it from the graph and let me know. Tell me. Which metal has more work function?
B. Metal B, sir.
B has more work function and A has less work function. This is how the graph between kinetic energy and frequency will come if it ever comes in your NEET ka exam. Everyone has understood this?
Yes, sir.
Yes, sir. Then, sir, please, sir, note, sir. Tan theta is H. Just draw this much. It's right there on your screen, big screen. I hope you can see it clearly because I can see it clearly on my screen. I'll give you a minute to note it down. This is graph between kinetic energy and the frequency.
Done, sir.
Done, sir. Well, sir. Done, sir. Good, sir. Remember the same equation which I wrote it in this form of W naught. I can write this W naught, which is the work function. Again, previous class. I can write this W naught, which is the work function, in a different way. How can I write W naught in a different way? Work function. We saw the relation between work function and something. Tell me.
C.
Yes?
C.
You can write the work function as E. Huh?
C. Speed of light.
What E? See, that is the problem, bacha. If you don't study, don't go through the last class and you sit in the next class, you are all at sea and you are sending SOS messages. Save our souls.
HC by lambda naught.
Yes, but tell me it in terms of frequency, F naught. What is W naught in terms of F naught, bacha?
HF naught.
HF naught. So I could have written this equation, which I'm going to write it in the space that I'm left with. K will be equal to HF minus HF naught. Do we understand this? Still the graph remains same. Here instead of W naught, I will write it as HF naught of body A. And here I will write it as HF naught of body
B.
Do we understand this?
Yes, sir.
Yes, sir. No, sir. Then please, sir, write, sir, the other equation, sir. Because in the examination hall, I mean, things could take any turn. And we must be what? We must be prepared for all the turns and twists that examination people can give us. Have we noted it down, bacha?
Yes,
Oops.
sir. Done. Completed.
Done, completed. Then comes the new. Not the new. But another graph. 5.2. This graph is the next graph, and this graph comes on your board right now. As you can see, this is the next graph. Graph between stopping potential V naught and the frequency F. Do we understand this? So now what I have done here, bacha, nothing very extravagant. HF is already there, yes or no?
Yes, sir.
Phi naught is W naught, it is already there. Instead of kinetic energy maximum, I have just written E into V naught. Do we understand this? Where V naught is the stopping potential, yes or no?
Yes, sir.
Yes, sir, no, sir. Then I just write V naught as E goes from here and it gets divided over here. So E goes here and E goes here. Yes or no?
Yes, sir.
The slope of this gentleman graph becomes H by E, which is same for all metals. Yes or no?
Yes, sir.
Then, sir, please, sir, write, sir. Then, sir, I shall will, sir, show you the graph, sir, in big thing, sir. Note this one down, then I'll show you the graph. You will be surprised to see that the graph is looking same. Yes or no?
Yes, sir.
Have you written this?
No, sir.
Right, sir? Please, sir. Thank you, sir.
Done, sir.
Done this?
Yes, sir.
Then, sir, what, sir? Comes the graph, sir. And here is the graph. And you understand the graph is exactly similar. Yes or no?
Yes, sir.
The only thing that has changed,
K might not change.
that the tan of this theta will not be equal to h. We understand this?
Yes, sir.
What will be tan of this theta equal to, bacha? It will be same for all the metals. What will be the tan of this theta equal to? Tan of this theta. Yes,
H
tell
by
me.
E.
Yes, it will be h by E. Remember, h is a constant, Planck's constant. We can't change it. E is the charge of an electron, which is constant. We can't change it. And hence the slope will be same for all the graphs, but slope of this graph and slope of that graph are not same, because slope of that graph was h, slope of this graph is h by E. Similarly, on this side, the y-intercept, we don't get the work function, but we get work function divided by E. The first one is the work function of A divided by E. The second one is the work function of B divided by E. I hope everyone has understood this. Yes or no?
Yes, sir.
Please note it down, sir.
Done, sir.
Done, sir. Just a minute, sir. Let me get you the next picture on board. And this picture is, again, whatever we are doing, trust me, the same questions will come, the same theory will come as questions straight away in your examination hall. And this is one thing, I've seen a question come of this, and that is why I am doing this, something known as quantum efficiency. A topic known as quantum efficiency. This is nothing to be worried about. Just write this formula, quantum efficiency. Basically, what does this quantum efficiency means? It's very simple. This is a surface, photoelectric surface. Light falls on it, dum 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 dum. Electrons get emitted, dum 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 dum. What is efficiency? How do you measure efficiency? Efficiency is always output divided by input into 100. Yes or no?
Yes, sir.
That's it. What is the input? Input is the number of photons. Yes or no?
Yes, sir.
What is the output?
Emitted frequency.
Not frequency. Emitted number of electrons. Yes or no?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir. No, sir. No, sir. That is the thing, sir. That is known as the quantum efficiency, sir. Number of numbers of electrons emitted divided by the number of photons which are falling. Yes or no?
Yes, sir.
That's it, sir. So that is x. If I want to find it in terms of percentage, x will be equal to number of electrons emitted divided by number of photons that are falling multiplied by 100. And now the answer would be in percentage. I hope it is clear to all. Please note it down. Any doubts on this one, bacha?
No, sir.
Okay, sir. Please, sir. Note, sir. Just give me a minute, sir. I'll just get my water, sir. Have you noted this down, bacha?
Yes, sir.
Yes, sir. Then again, I have seen a question on this photoelectric current. How much? They might ask you. They may not ask you how much is the number of electrons that are emitted. They can ask you what is the photoelectric current. So how do you find the photoelectric current? You just find how much electrons are emitted. So from there you can find out the value of the charge, how much charge has been emitted. Yes or no?
Yes, sir.
You divide that charge by time and you will get the photoelectric current. Yes or no?
Yes, sir.
Here E stands for charge, which is 1.6 into 10 raised to the power minus 19. We understand this?
Sir.
Here small ne, capital Ne is the total number of electrons that are emitted. Small ne is the number of electrons per unit time. Do you remember it? Capital Ne, small ne.
Yes, sir.
Small ne is the number of electrons emitted per second. If I multiply it with the charge of an electron, you will get the photoelectric current. Do we understand this? Can I have some raised hands from everyone in the class that we understand this, how we have done this?
Yes, sir.
Raise hands. It's a good exercise that you raise hands. Only one student has raised hand. What about the others? What about the girls? We are all there. Okay, chalo. Okay? Please note it down. I'll give you a minute to note it down. Then I shall move forward. Have you noted this down, Becha? Everyone?
Yes, sir.
Okay. Then these 3 points again, same thing has been repeated over again. Remember, all these points are going to come in the examination or Einstein photoelectric equation is based on the conservation of energy. Yes or no? Did I tell you that?
Yes, sir.
It can come in a straightforward question. Einstein explained the photoelectric effect on the basis of which theory?
Quantum theory.
Particle theory or quantum theory. Quantum theory was given by Planck, Planck's constant, Planck, and he was awarded a Nobel Prize. I told you that, right? According to Einstein, one photon can eject only one electron. Yes or no? Collision, dung 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 dung. That jig 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 was coming and it was ejecting this. But here the energy of the photon must be greater than or equal to work function. Its frequency must be more than threshold frequency and its wavelength must be less than the threshold wavelength. Do we understand this? Yes or no?
Yes, sir.
Yes, sir. No, sir. Better I go, sir. No, sir. Where should I go, sir? I should remain here, sir. And just to make a point, we are going to solve a question and see what type of questions. Oops.
Sir, please give us a minute.
Yes, it is. You have the entire time in the entire universe. Don't worry about time. You have enough time. I'll give you. Don't worry. You are noting this down, bacha?
Yes, sir.
Yes, note it down. Not a problem. Not a problem. I'll give you enough time. Note it down. Till then, I'll just do ding with my thing. Have you done this? Everything I told you, if you just remember 3 or 4 things, the entire chapter is covered. And if you get a question on this chapter, you can just tick it and go away. It will hardly take 5 seconds of your time. Shall we move ahead, bacha?
1 second, sir.
1 second, sir. Okay, sir. I'll give you 1 second of your time.
Completed, sir.
Completed, sir. Then, sir, you have 5 seconds, sir. 5 to 6 seconds I'll give you. The question is going to come drop on your screen in a flash. And then you will have to give the answer in 5 to 10 seconds. Countdown begins. 3, 2, 1. Oops, the question has come, but you can hardly see the question. Why you're not able to see the entire question? It's shameful. Okay. According to Einstein's photoelectric equation, the graph between the kinetic energy and the photoelectrons ejected and the frequency of the incident radiation is what? And the graphs are here. Dun, dun, dun. Which graph is the correct one? And your time starts now. Your time also ends. Where is the answer? No answer. Shameful act. No answer. Graph between kinetic energy.
Sir, C.
Sir, see. Yes, sir, see. We see. I see. You see. Everyone sees. Everyone sees that. Yes or no?
Yes, sir.
I don't see everyone, sir. Can I have some wave of hands that we understand this? Same thing that we did in theory is coming as question. This is how questions are framed. We got this?
Yes, sir.
Yes, sir. No, sir. Then, sir, next question, sir. The next question comes here. Tan, tan, tan. Why I'm not seeing this entire thing, yeah? I mean, I'm amazed. Just give me a moment. I'll do some jittig, jittig, jittig. Why I'm not able to see this? Make it smaller. Then make it larger. Probably this will make sense now. Let me see if this makes sense. So here it comes and here it goes here. And then I do this. Probably it was more zoomed. Now I hope you can see the entire question. You can see the entire question or not? Still the question is getting cut. What's wrong? Can you see the entire question or not?
Yes, sir.
But I can't see it. Why can't I see it? What is wrong with my screen? Something is wrong somewhere. What is wrong where? That is what I can't understand. Let me do it this way. Still, I'm not able to see the entire question. What is wrong here? Maybe I'll just bring this thing up. Maybe I bring this thing down. Something is wrong. I don't know what is wrong. Just give me a minute. I will have to sort this out. What is wrong here? What is wrong here? Why I can't see this entire thing? If I just make it here like this, then what happens? Oh, stupid things happen in life. Okay, now you see this. Okay, chalo, we'll have to work on this. So what we are going to do is to solve question number, which one? Question number 25. Do you understand the question?
No, sir.
The figure shows a plot of photocurrent. So I have drawn photocurrent here. And I have drawn the anode potential. That means the potential difference between the anode and the cathode, VAC. Do we remember this? See, you don't remember the graph. That is a problem. How do I find a solution to this problem? Because the solution to this problem basically lies where? Basically lies in what we had done in the previous class. If I do this, everything goes away. So that is the problem. When I'm making it shorter, everything is going away. So I make it longer. Okay. Yes. So how do I solve this? This is a graph between photocurrent and anode potential. Do you remember this graph? Do you remember this graph?
No, sir.
No, sir. That is the problem, sir. That we seem to forget things. If we seem to forget things in life, then how will we move ahead in life, bacha? You have forgotten the graph. Between what and what? We have done it 2 or 3 times. Remember this. Again, I'll have to show this. I don't like going back in the past because that is against the laws of physics. Right now, we just can't go back in the past. Do you remember this graph?
Yes, sir.
See, you have to go back in the past. That's not a good thing. We are breaking the laws of physics, the present laws of physics that prohibit us from going into the past. Not only helps us in going into the future. Then we also saw this graph. Bacha, I'm really very disheartened by your not studying. Anyways, I can't do anything about it. Then this graph, effect of frequency. Did we see that or not?
Yes, sir.
But you don't remember it, sir. So what is the faida of seeing it? So if you don't remember this graph, you will not be able to solve this question. So I will have uh, as a lesson to you, we'll skip this question and move ahead with the next question because else you will never learn. You have to learn that if you make a mistake, you have to pay a price. So that question, you will have to do it on your own. Again, the same problem. What is wrong with this? What's wrong with this entire thing? I don't understand. Okay, चलो इतने पे काम हो जा रहा है. The maximum kinetic energy of a photoelectron varies with frequency. See, same question in 2 different years. What is the answer?
D, sir.
Which one?
D, Delhi.
Okay, D for Delhi, D for Delhi, D for Delhi, D for Delhi. Same question, you can see. As I told you, all these people, when I say all these people, I mean the people for NEET, they don't spend enough time in framing a question because it's a waste of time. So what they do is they just copy the question from the previous year. This is CPMT. When at that time CPMT used to be your NEET, and it used to be very tough. Can you tell me the answer for this one?
B, sir. Bombay.
Verb function of A is B for Bombay. Yes. Bombay, have you? Where did you hear the term Bombay? You know, no one calls it Bombay anymore. Bombay was the English version of the name of Mumbai. Mumbai is the original version, and Bombay is the distorted version. Do you understand this? Mumbai.
Yes, sir. B for Bhubaneswar.
Yes, beta.
Bhubaneswar.
Okay. And there was a point in time where your CST, Chhatrapati Shivaji Terminus, was known as VT. Do you know this? Victoria
Yes,
Terminus. It was known as Victoria Terminus. And that was a time when I used to live in Mumbai, when it was known as VT. When it became CST, I actually left Mumbai. This one, see, same question repeated in different exams and with different things, right? What is the answer for this one? Are we don't have an answer? Shameful.
sir.
We don't have an answer. Graph is what maximum kinetic energy of electron with frequency of incident radiation, incident photon. The slope of the curve will be
C.
Planck's constant. If this was between V naught and F, the slope will be Planck constant divided by E. Yes or no? We understand this?
Yes, sir.
Okay. That is how questions on graph has come. As you can see, this graph, which is the graph between kinetic energy and frequency, that comes many more times. So that is why we have done this graph. At this point in time, I would like to take a small pause. 2 minutes, not silence. You don't keep silence. I mean, no one has departed, so we'll keep silence. Yes, something has departed. What has departed? This topic, photoelectric effect, has departed, has said goodbye. So if he has said goodbye, we'll have to pause here for 2 minutes to say a final goodbye to this departed soul. And I'll give you this time to ponder if there is anything that you have not understood, please let me know. I'll give you 2 minutes to go through the entire topic of photoelectric effect. If there's any doubt in your head, let me know. We will clear it now itself. 2 minutes, and then we will move on to the next topic. 2 minutes silence. 2 minutes for all of you to see what we have done. Any doubt, please let me know. Then we shall move on to the next topic. Anything that puzzles you? We will be dealing with it.
Sir, two topics, sir.
Yes, beta?
Intensity of light and effect of frequency graph.
What have you not understood in that?
Sir, intensity of light, sir.
What intensity? Intensity of light is gauged by the number of photons. Yes or no?
Yes, sir.
What have you not understood in that, beta? Tell me. What should I clarify? Tell me and I clarify it. I'll just go back to where I was. Okay, this is the point where I was. Right. So what have you not understood? What have you not understood here? Tell me. If I talk about intensity of light, I'm talking about how much light is falling. How much light is falling depends on how much photons, the number of photons which are falling. When I refer to the energy of light, I refer to how much energy that light has, and that is determined by the frequency of the radiation and not by the number of photons that are falling on it. What
Sir,
doubt
that
you have?
power
What
by
doubt you?
area, sir.
What doubt you have, beta?
Intensity equals to power by area, sir. P by A.
Yes,
That topic, sir.
that is just a formula. You just remember. You just remember the formula, beta.
Sir, after that, NHF by 80.
After that, what?
NHF by 80.
NH580.
NHF by 80.
No, 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 no. Sorry. What are you saying, beta? NH by 80. What are you saying?
NHF by 80.
Sorry, I'm not able to get you what you are saying. NH by 18. What?
Intensity I is equals to NHV by 80. The first topic, sir. Intensity of light, first topic.
You just have to remember the formula, beta. There, nothing else. You just have to remember the formula.
Okay, sir.
You just have to remember the formula, nothing else.
Okay.
Nothing that you have to understand there. We just found out intensity is how much light is falling, how much energy is falling per unit area, per unit time. That is the basic definition. And from that basic definition, we have formulated a number of formulas. The formula that you are talking about is one of that formula. Got it?
Yes, sir. Sir,
So you will just have to remember it, beta.
okay, sir. Effect of frequency graph, sir.
Effect of frequency graph.
Yes, sir.
So if I increase frequency, the stopping potential will increase, but the saturation current remains same.
Intensity is same.
If the intensity is same, saturation current will remain same. If frequency is same, stopping voltage will remain same. If you change intensity, saturation current will change. If you change frequency, stopping potential will change. Am I clear?
Okay, sir.
Frequency relates to stopping potential. Intensity relates to the saturation current. Intensity relates to number of photons. Energy comes from the frequency of photon. Since it is energy, therefore it relates to the work function. Do we understand this?
Yes, sir.
Shall we move ahead now? I'll give you still 1 more minute. If there's anything else, please let me know so that I can clear it, because we will not get any chance to revisit this topic again. We're not going to come back to this topic again. So this is your, yes,
Okay, sir. Completed.
completed, everyone?
Yes, sir.
Can I have some raise hand that we have understood this and we have no doubts on this? Everyone?
Yes, sir. No doubt, sir.
Okay then. Since this is settled, we will move on to the next topic, and the next topic is known as matter wave. Heard about this matter wave? Heard about this matter wave? We know that light has a dual nature. Yes or no?
Yes, sir.
Some phenomena can be explained by the wave theory of light. Basically, we are talking about interference. It cannot be explained by the particle theory of light. Some phenomena can be explained only by the particle or the quantum theory of light. Which is the phenomena which can be explained by the quantum theory of light? Question. Which is the phenomena which can only be explained by the quantum theory of light? Particle theory of light. Which is that phenomena I am talking about? I'm waiting for your answer. Which is the phenomena that we are talking about, which can only be explained by quantum theory of light? Just finished it and just came to the next topic. Photoelectric effect is the phenomena that can be explained by the quantum theory of light. We have done the entire topic and we don't know what is explained. Anyways, there are some phenomena which can be explained by both particle theory and wave theory, whether it be reflection, refraction, or polarization. We can explain it by both the theories. That means light nature depends on the experimental phenomena. This is known as dual nature of light. The wave nature and the dual and the particle nature cannot be possible simultaneously. So light will either have wave nature or will have particle nature. It cannot have both the nature simultaneously. But sometimes it behaves as particle and sometimes it behaves as wave. Do we understand this?
Yes, sir.
Okay. Then since we saw this, since we understood this that light can have both natures, light can sometimes behave as wave, sometimes it can behave as particle. When it is interference, it behaves as wave. When it is photoelectric effect, it behaves as a particle. Can other objects, other matter have similar nature? And that prompted one of the great scientists, De-Broglie, to think on this and give a hypothesis which is known as the De-Broglie hypothesis. What did he say? He imagined that if light, which is energy, thermo radiations, possess both nature, it has a wave as a particle nature. Similarly, any matter must also possess both nature. I am one matter, I am a particle, I have matter. So I have both natures. I have a particle nature as well as a wave nature. Any matter can have both the natures. It can have a particle nature as well as the wave nature. Do we understand this?
Yes, sir.
De Broglie imagined that despite particle nature of matter, wave must also be associated with material particles. Example, a very fast moving airplane. Why it should move very fast? We understand it when we get into the theory part. A plane is matter, it is a particle, it is one thing, it is particle. It moves as one particle, it does not move as a wave, it moves as particle. But since you can see it as a particle, it is moving as a particle, it is moving as a packet, it also has a wave nature associated with it. Now plane might be very big. If I make it smaller, this particle nature and wave nature become very close to each other. A very fast moving electron is very small, but if it is moving very fast, electron is a particle. We can't call it a wave. Electron is a particle, but if a very small if an electron is moving at very high speeds, it also has a wave nature. In fact, any matter which is moving at any speed, which has got any momentum, De-Broglie says that, wait. Even though it's a particle, but since it is moving, it has velocity, it has energy, it has momentum, it is also behaving as a wave. And these waves, which are associated with particles, I am a particle, but I start to move, I also become a wave. These waves are known as matter waves. Do we understand what I have babbled just now? If a wave can behave as a particle can also behave as a wave. These waves, which are associated with particles, remember they are not real waves, they are imaginary waves. These imaginary waves, which are associated with particles, are known as matter waves. Do we understand this?
Yes, sir.
What are matter waves? Any particle, if it is moving, you can think it of as a wave. These imaginary waves are known as matter waves. I'll give you a minute to note it down. I hope you have understood this. Yes or no?
Yes, sir.
Please note it down. This is what De-Broglie suggested, that every particle which is moving can also be thought of as a wave, and here comes his hypothesis. When I say hypothesis, you just can't prove it maybe. It's a theory which sounds good, which explains a lot of things. Call it hypothesis. De-Broglie's hypothesis. Every particle is associated with a wave nature. Light has both nature, so why can't we have both natures? Particles also have both natures. They have a particle nature because they are particles. They also have a wave nature. These waves, which are associated with particles, are known as matter waves. Have we understood this?
Yes, sir.
Have we noted this down?
Oh, sir. 30 seconds.
Please note it down. You will get this sheet ASAP as soon as possible. I'll give you a minute to note it down. Have you noted it down, beta?
Yes, sir. Done, sir.
Okay, sir. Now, since we have thought of as particle as wave, every wave has a wavelength. Yes or no? Yes or no? Every wave has a wavelength. Yes or no?
Yes, sir.
So this matter waves associated with particle will also have a wavelength. How do we calculate this? The process is very simple. Every particle which is moving has a kinetic energy. This kinetic energy is half mv square. Yes or no?
Yes, sir.
We can write it as p square by 2m, where p is the momentum of the particle, p is equal to mv, which can be written as root over 2m into kinetic energy. Yes or no?
Yes, sir.
Now, according to De-Broglie theory, how do I find the wavelength associated with a particle? This is the most important part of this. The wavelength associated with a particle is found by this formula. The wavelength associated is h divided by p. What is h be here, bacha?
Planck's constant.
Yes, h is a Planck's constant. Our old hero, Planck's constant. Yes, it is a Planck's constant. What about p here, bacha?
Momentum.
P is the momentum. That is correct. I'm making it bigger. Right now, it comes on your screen. The lambda, or you can write it as lambda m. M standing for the matter wave. Do we understand this? Lambda of this matter wave is h divided by p. H is the Planck's constant. P is the momentum. I can write it as h divided by mv, or h divided by root of 2m. M is the mass of the particle, and E is the kinetic energy of the particle. Do we understand this? Can I have some reason that we understand this? Matter waves, one question can come from these matter waves. You understand this?
Yes, sir.
That means this lambda is inversely proportional to momentum. More the momentum, less the lambda. It is inversely proportional to velocity. More the velocity, less is the lambda. It is inversely proportional to root over kinetic energy. More the kinetic energy, less is the wavelength. Do we understand this? I'll give you a minute to note it down. Have you noted this down, Bacha?
Yes, sir. Sir, full upward, sir. We need to write apart.
What, Beta? This is
Full
the only
upward.
thing. This is the only thing that you need to write, Beta. The wavelength associate. We call this wavelength as De-Broglie wavelength, or we call it the wavelength of the matter waves. This is the only formula that you need to write. Nothing else. Do you understand this?
Yes, sir.
In the above thing, what we have is energy is half mv square. Kinetic energy is half mv square. Momentum is m into v. Momentum becomes root over 2 me. You know this, na? Yes or no?
Yes, sir.
This is the only thing that you need to remember. This wavelength is known as the Broglie wavelength of matter waves. Will you remember this?
Yes, sir.
Do not forget it in your entire life until you pass your NEET, because a question will come on this. I always believe that one question will always be there from matter waves or from photoelectric effect. Out of this topic, you must get one question. It's a certainty that you will get one question, and if you are lucky enough, you might get two, and you can mark out those two questions and stay happy in your life. Have you done this? De Broglie wavelength.
Yes, sir.
Yes, sir. No, sir. Everyone is there, sir. So I shall move on, sir. And now I'll give you some shortcuts of calculating this. So I mean, the theory is this much. After this, everything else is manipulation. What I mean by manipulation, energy is this. I can write it in this form. Then I can make the formula like this. All these are manipulation. The entire theory is right now on your screens. Every question that comes on matter waves is right on your screen. Do we understand this? Every question that can come on matter wave is right on your screen based on this 3 letters or 3 words or 3 alphabets that you've seen. Now I can just experiment more, and what do I see? I can go back. De Broglie wavelength. I have talked about De Broglie wavelength. Now, normally when this question of De Broglie wavelength comes, it might not come on a jet plane moving at a high speed, or a train moving at a high speed, or a missile moving at a supersonic speed. You might have heard that BrahMos was accidentally fired, and it struck Pakistan, and now we have a test fire of BrahMos, which is a hypersonic or a supersonic missile. They can obviously make a question on a supersonic missile because it is also, when it is moving, it has momentum, it has a matter wave. Wavelength is very large, that's why we don't see it. The most of the questions that are going to come on this matter waves will be based on charged particles. Now, when I say charged particles, I mean, what are the charged particles that can come to you as questions in the examination hall? The charged particle could be it has to be a particle, single thing. It has to be a particle, single thing. The charged particle could be a what? And how many charged particles you know in your life? The simplest one is an electron. We know this, electron.
Yes, sir.
Then, if I give the example of an electron as a charged particle, what is the next thing that comes to your mind? Proton. That is also a charged particle. So most of the question will come either on electron, proton, or one or two things. So we'll just now see it. The kinetic energy of a charged particle or any particle is half mv square. Yes or no?
Yes, sir.
Now, how do you accelerate these charged particles? You accelerate it by applying a potential V, potential difference V. We multiply it by the charge of that particle. Q into V becomes its kinetic energy. Yes or no? We have discussed this. Yes or no?
Yes, sir.
Where Q is the charge of the particle, momentum is m into V. The formula is root over 2 into m into kinetic energy. Now it becomes root over 2 mqv. Do we understand this?
Yes, sir.
It is just a continuation of what we were doing. In the above, what we have written above is momentum is root over 2m into kinetic energy. Now I am writing it as root over 2m into q into v, where q is the charge of the particle and v is the potential difference. Yes or no?
Yes, sir.
Have you written this down, sir?
5 seconds.
Write it, sir. Because then I will do it bigger, sir, and then you will not be able to write it, sir. Same thing, continuation from what we were doing. Yes or no? We got this?
Yes, sir.
Yes, sir. No, sir. Then, sir, how do I find the De-Broglie wavelength? The De-Broglie wavelength will be given by h by p. We know this formula. Yes or no? Everything comes from this formula. Yes or no?
Yes, sir.
So now this becomes h divided by root over 2m into kinetic energy. Yes or no?
Yes, sir.
Then it becomes h divided by root over 2m q into v. Yes or no?
Yes, sir.
1 minute to note this down. Have you noted this down?
Yes, sir. Computer.
Well done, sir. Then, sir, what, sir? Now, let us go on to the first particle, and you don't have to note it down. You just have to remember the formula. So, the first particle is an electron. Mass of an electron is this much. You may not know it, but this is the value. Charge of an electron is this much. You may not know the value, but this is the value. Planck's constant is this much. You may not know the value, but this is the value. Yes or no?
Yes, sir.
So, what we are going to do is just put the values for the electron in the De-Broglie's equation, and we get this formula. This is how it is derived. You just have to remember the final result. I'm showing you the entire derivation. They have just put the values at different places, and here they have arrived at the De-Broglie wavelength. This becomes the shortest possible formula by putting all the values, and we get lambda is inversely proportional to the voltage difference. Do we understand this?
Yes, sir.
How did I get that formula? I just put the values there and calculated this, and 12.27 divided by under root of V Armstrong unit, and potential difference has to be in voltage. So this is the formula that comes for an electron. Now you have got two choices. Either you remember the original formula and put the values and get the result every time, or you remember the shortcut, which is the wavelength for an electron. Which one is a simpler task for you? I leave it to you. If you can remember all these individual formulas, very good. You can straight away get your answers. If you don't remember these shortcut formulae, you will have to do the entire exercise in the examination hall. Am I clear, bacha?
Yes, sir.
So this is the De-Broglie wavelength for an electron. Have you noted this down? Have you noted this down, bacha? De Broglie wavelength for an moving electron which is accelerated by a potential difference of V. Do we understand this, bacha?
Yes, sir.
The other formula is the reverse of this formula. We have been taken on the other hand side. Lambda has been brought to the denominator side and we have squared. So now the formula becomes, what is the potential difference required for an electron of wavelength lambda to stop? And the formula becomes this. If you remember any of these, you know the other formula. We understand this, yes or no?
Yes, sir.
Please note it down. I shall give you a minute. Remember, this is the De Broglie wavelength for an electron. How I've arrived at this magical formula? Nothing. I've just put the values in the equation and got this formula. Yes or no? We got this. Yes or no?
Yes, sir.
The first charged particle is electron. I hope you have noted this formula. Shall I move on to the next charged particle? What is the next charged particle?
Photon.
Next charged particle is a proton. I put the values of the mass of the proton, charge of the proton, and I arrive at this formula. In the first formula, you have 12.27 divided by root of V. In this formula, you have 0.286 divided by root V. This is the formula for a proton, straightforward formula. Do we understand this? Yes or no?
Yes, sir.
Please note it down, bacha. Remember, these formulas are not separate formulas. The formula is just one. Lambda is h divided by root over 2 m q v. We are just putting the values and making them smaller. We understand this? Yes or no? Can I have some reason that we understand this? They are not separate things. They have been arrived at from the same formula. We got this?
Yes, sir.
Yes, sir. Shall I move forward?
Yes, sir.
Yes, sir. No, sir. Then, sir, this, sir. Deuteron. Now, why I'm showing you the mass of a deuteron? Why I'm showing the mass of a deuteron? Because there are many questions that I've seen that come on electron, proton, deuteron, and alpha particles. And I want you to be very sure, very sure, very sure about the mass of a deuteron and the charge of a deuteron and mass of a alpha particle and mass of and the charge of an alpha particle. Now, what is a deuteron? Tell me, fatapat. This is chemistry. This is not maths. This is not physics. What is deuteron? So, The mass of a neutron is 2 times mass of a neutron. This is what you remember. Mass of a neutron is 2 times mass of a proton. Do we understand this?
Yes, sir.
Well done. And the charge of a neutron is same as the charge of the proton. Do we understand this?
Yes, sir.
And you will never forget this in your entire life. So please note this down. Once you note this down, and once you put this value, this is one thing that you must remember. Charge of a neutron is same as the charge of a proton, but mass of the neutron is 2 times the mass of the proton. If you remember this, neutron is basically the you know isotopes, yes or no? Hydrogen has isotopes.
Yes, sir.
In one isotope, you have 1 neutron and 1 proton, yes or no?
Yes, sir.
And if you remove that electron, that becomes your neutron. Got it?
Okay.
So the mass of this neutron consists of a nucleus. It consists of a neutron and a proton, and mass of neutron and proton are almost similar. That is why 2 times mass of the proton, and the electron is removed, so the charge is charge of a proton. The formula for neutron becomes 0.202 divided by √2v. Have you written this?
Yes, sir.
Have you noted down the important thing? Mass of the neutron is 2 times the mass of the proton. Have you written this?
Yes, sir.
Then comes the next particle. Again, the question may be based on this chapter. It may be based on a different chapter, but you must always remember that, and mark my words and mark this video. And when the question comes, you will thank me that one question will always be there in your entire paper, which has somehow related to electron, proton, neutron, and alpha particle. This is their favorite one. They always give it. Now coming to alpha particles, the next heading is alpha particles. Please note down for alpha particles. Alpha particles. How much is the mass of an alpha particle, bacha? 4 times the mass of proton. Will you remember this?
Yes, sir.
And what is the charge of an alpha particle? 2 times the charge of a proton. It is a helium nucleus. Do we know this?
Yes, sir.
Okay, sir. Then, sir, you just remember this, sir. And, sir, what do you do, sir? You just remember the formula for wavelength of this alpha particle, and the formula becomes 0.101 divided by √v. Now, how do you keep on remembering this formula? You just make a list of all this formula and paste it. Wherever you sleep, you paste it on your ceiling, or if you are sitting, you paste it on your wall right in front of you. So every time you just see this formula, and that is how you will remember this. You will have to see them every day, every second, every hour, every minute of your life from now onwards till the day you give your exam. And that is the only way, that is the only shortcut I have for you to remember these. If you can follow my advice, well done. If you don't follow it, well, India is a democratic country. We have all rights, right? So you can exercise that right and stay happy in your life. Do we understand this?
Yes, sir.
Have we noted this down? These were charged particles. Do we understand them? Electron, proton, alpha, and neutron. Do we understand this?
Yes, sir.
Shall I move ahead? We have noted this down.
1 second, sir.
The only way you can remember this is by reading them again and again and again and again and again and again. There was a doha in Hindi, which I would like to state. Karat karat abhyas ke jarmati ho sujan. After that, something, I don't remember it. So basically, it means Kavita said this, that, you know, if you practice a lot, even you don't have any brains, you will become smart. And the example he says that once you are taking out water from a well using a rope, the well is made up of stones. You are using a rope, but with repeated rope going up and rope going down, even the stone will get marks of that rope. Rope is very soft, stone is very hard, but even a rope will scratch the stone. Do we understand this? So you have to see it every day in your life, every minute in your life, every second in your life. That is how you can get better on this. Shall we move ahead?
Yes, sir.
Yes, sir. No, sir. Then, sir. Again, the same thing repeats, sir. If you have an uncharged particle, kinetic energy is half mv square. You can write it as p square by m. M is the mass, v is the velocity, p is the momentum. Velocity becomes this, momentum becomes this, wavelength becomes this. Is this clear to everyone?
Yes, sir.
Do you need to note it down again? If you need to note it down again, you do it, else we will move ahead in life. Life has to go on. Life has to go on and on and on and on and on and on and on.
Sir, move on, sir.
Yes, sir.
Move on, sir.
Let us move on. And in this uncharged particle, there is a particle that we have missed. And the particle that we have missed is your neutron. Yes or no? It cannot be accelerated by a potential difference. So I'll have to say it in some other way. The kinetic energy of this particle in terms of its wavelength can be written in this form. Yes or no? The
Yes,
different ways of writing the same thing, beta. The more, the number of ways you know, the quicker you can do the question. So the formula for a neutron becomes 0.286 divided by root over E, where root over E is root over the kinetic energy. Now this formula we have arrived from whatever values we have put here. This formula can be used for a neutron because we know the mass of a neutron and we have put all the mass. Remember, mass of a neutron is exactly similar, very similar to the mass of a proton. Do we understand this?
Yes, sir.
So this formula now becomes valid for a neutron. I'll give you a minute to write the formula for the neutron. Have you written this, bacha?
2 seconds, sir.
2 seconds. 1 second, 2 seconds over. Shall I move on? Okay, I'll give you more time.
Sir, have you sent sheet of this chapter, sir?
Yes, bacha?
Have you sent this sheet of this chapter?
Yes, sir. I have sent this sheets of matter wave, sir. I have done my job, sir. I always do my job, sir.
Sir, to whom you have sent, sir?
I have some email IDs. I've sent it to those email IDs.
Okay.
There's the office email IDs. I hope it is there with. Probably one of the IDs is for you for here. I don't know who has those email IDs. I sent it yesterday night around 10:50. If you got this, shall I move on?
Yes, sir.
Yes, sir. No, sir. Then, sir, the last thing, sir, which may come. The question, sir, is Bohr quantization condition. Do you know this? The only thing that you must remember is the condition for a Bohr's orbit is mvr, which is the angular momentum is nh by 2 pi. Do we know this?
Yes, sir.
Please note it down, sir, because this is very important, sir, because many questions can be solved using this phenomena, the condition for optimization for a Bohr's orbit, for what values of Bohr's, for what value does a Bohr orbit exist? And I've made it big so that you can see it with the right eyes wide open. MVI is equal to NH by 2 pi. That's it. You need to remember this. Please note it down, bacha. Have you noted it down, beta?
Done, sir.
Okay, then we'll do 1 or 2 questions because everything has already been done. So this is the question that comes. The De-Broglie wave. This is the IPMT, which is your NEET, whatever. The De-Broglie wave corresponding to a particle of mass and velocity v has a wavelength associated with how much? Waiting for your answers. Remember, this is in the year 1992.
A.
And the answer is A. And you can see.
A,
And
sir.
A, sir. What, sir? A, sir. Okay, sir. Then you can see, as I told you, they have a lot of creativity. And the creativity that they use is this one. You see? This is the question in the next year's AIP. So you understand now how they create questions? One question can be put in different forms and they just put the different form and they get the answer. Do you understand this? How questions are created?
Yes, sir.
Yes, sir. What is the answer, sir, for this one, sir?
Sir, option A, sir.
Yes, sir. See, sir. That's how they make the question, sir. See, sir. Next question, sir. Straightforward question. We have already done it in the exercise. The De-Broglie wavelength of an alpha particle. We have done this, yes or no?
Option C, sir. Chhattisgarh.
See? So that is the power of you remembering a lot of things. See, this is again CPMT. They don't have any creativity. They will just copy the question from the previous year. Do you understand this?
Yes, sir.
Anyone understand this? Can I have some participation from other students? We understand this. So if you just remember what we have done in the class,
sir.
everything is going to be coming on the same line. See, this is 93. Same thing, just put in different ways. Do we understand this? Same thing, put in different ways, and you have different questions coming in. We got this, yes or no? Got this, yes or no, bacha? You have to find the velocity, not the kinetic energy. The formula we have is in terms of velocity. Is in terms of kinetic energy. You can do it. Yes or no?
How, sir?
Okay. Let us move on to this question, which is from latest thing. And these are the type of questions that are more in the business today. So what we have done here, electrons used in an electron microscope. Oops, why this has happened? Okay, make it like this. Okay, electrons used in a electron microscope, they are accelerated by a potential difference of 25 kilowatt. Now I have changed it to 100 kilowatt. What will be the De-Broglie wavelength? Will it decrease, increase, increase, decrease? What will happen? We know the relation, yes or no?
Sir, B.
Decrease or increase?
Decrease.
Yes, decrease by 4 times. See, that is the problem. You have lost 5 marks. Why you have lost 5 marks? Because you have not used your head. Do we remember this wavelength is inversely proportional to 1 by root over V? Yes or no?
Yes, sir.
This was root over V and you did not see that root over V. So your voltage has become 4 times. So what will be the change in the wavelength? The wavelength will be, this has become 4 times. So root of 4 is how much? 2. So the wavelength will decrease twice. Do we understand this? Can I have some raise hand that we understand this?
Okay, sir.
Okay, sir. Nahi, sir. You have to remember all these things, sir, in the examination hall, sir, because sir cannot come and give you exam, sir. You understand this?
Yes, sir.
That means if the potential becomes 9 times, then the wavelength will be decreased by
3 times.
the potential difference becomes 16 times, wavelength will be decreased by a factor of
4 times.
4. So that's it. That's all about matter waves and photoelectric effect that we are done. The sheet is already there on your way. You will get it and you can solve the remaining question because they are on the same category. The question that I found different, we have solved this in the class. Anyone has any doubts? Please let me know. Else the class is done and dusted from my side. I hope you practice. The next class, I will start with the next topic. Okay.
Sir, what about the answer of before question, sir?
Yes, beta. Which one?
53 something, sir.
Okay,
Question
we will discuss in the next class. I have I've forgotten the question, so the
Sir,
time is
syllabus
over.
for
I'll let.
weekend, sir.
Yes, beta.
Weekend syllabus.
Weekend syllabus. I don't know. I'm not given any question, so I don't know.
Okay, sir. Okay.
If I had given any question, I would have told you. If I have not given any question, how do I tell you?
Okay, sir. I understand.
Okay. Take care. Have a nice day and study. When you come to the next class, study. But remember the next class, even if you don't study in this class, the next class is a different topic. So your life still goes on. But that doesn't mean that you don't study, okay? Take care and have a nice day.
Okay, sir. Bye, sir.